Hey guys, I created a new worksheet for you for today. It mirrors the quiz a little bit better than the one that's in your packet, but worksheet D in your packet is still really good to use, so feel free to use that one as extra practice as needed. So follow along with this worksheet. You can jot the problems down somewhere else or take screenshots as you go, whichever you choose. So here we go. Quiz is tomorrow. All right, so the first part, we're just going to be putting stuff back into radical form. Remember, we have the rational expression right here with the with that fraction as an exponent, and the power is what is in the numerator, the root is what is in the denominator. So put it back into radical form, and under your radical, you need the root on the outside. That's called the index. Put that in that spot, and then you put whatever term you have raised to the power on the inside under the radical. Your other option is to still have the root on the outside, but then put everything in parentheses and raise all of that as long as every single term is raised to the to that power. So first two examples, they should be pretty easy. We are going to take the third root or the cubed root of both 7v and raise them both to the fourth power, so that answer is fine. Or you can also see it as 7v, to the fourth inside parentheses under the radical. So either of those solutions are perfect. And there we go. Exact same thing is going to follow for number 2. We are going to take the fourth root, so the fourth root of, and then our power is going to be the third power, so of the term 3x to the third power. Or you could write it again with 3x under the radical, under your fourth root, and everything raised to the third power. There you go. First two. Done. All right, numbers 3 and 4, we're going to take it from radical back into rational exponents. So remember, our root is in the hook, our power is outside parentheses or inside, depending on how it's written. So as we write it, remember flower power, the flower grows above the ground, that's our power, and the root is always under the ground, so that'll be the denominator in our fraction. So we have the entire term, 3n, all of that is raised to the fifth power, and you take the fourth root. Done. Same thing for number 4. We are going to take the cubed root of 5m raised to the second power, or raised or squared if you want to say it that way. So it would be 5m raised to the power of 2/3, or 2 over 3. Those are those two. All right, our next section, we're actually going to be simplifying. So remember, a power to a power, so we're going to multiply those powers inside. If it helps you to rewrite it in radical form, by all means do so. That might help you when you're evaluating the numbers. So we've got 64 to the 3 halves, because that had a power of 1, and 1 times 3 halves is 3 halves. And then x to the power of, what is 6 times 3 halves? Remember, that's 6 over 1. So that would be 18 over 2, or just 9. So that'll be x to the 9th at the back end. All right, so simplifying the 64 to the 3 halves, that means take the second root. Take the second root. Why is that not writing? Feel like we're in class, seriously. All right, or the square root of 64, and we're going to take that solution and then cube it, times x to the 9th. So the square root of 64 is 8, so that'll be 8 cubed times x to the 9th, and 8 times 8 times 8, we know that 8 times 8, the first two, is 64, so 64 times another 8 will give you 512. So your final solution when you're simplifying is 512 times x to the 9th power. That's as small as that one gets. All right, example 6, we are going to take the third root, or the cubed root, of 27p to the 9th raised to the first power. So we're going to, again, multiply that power inside to each of the terms. 27 already has a power of 1, so 1 times 1/3 will give me 27 to the 1/3 power. P to the 9th times 1/3, so 9 times 1/3. That would give me P to the 9/3, and then we can simplify that to become P to the 3rd. Don't forget your 27 to the 1/3 power. That means take the cubed root of 27 and raise it to the 1st. So what's the same number 3 times that gives us 27? 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. And 3 times 3 is 9. Times another 3 does give us 27. So the cubed root of 27 simplifies just to give us 3. And then that P to the 9/3 turned to be P cubed. So your final answer is 3 times P cubed. All right, we are about halfway done. Our next section, we are going to use those properties of exponents again, and we're going to use the product power, or excuse me, product property, my bad. So in that case, you are going to, as we talked about on Friday, add your exponents. If we have the quotient property, then we are going to subtract the exponents. And like you just saw in the last couple of examples, if you have the power property, then you are going to multiply your powers. All right, so in example 7, we have 3 to the 2/3 times 2 to the 1/2. You can always go ahead and just multiply those coefficients, so you can rearrange multiplication however you choose. So I want to get the coefficients together, and then I want to go ahead and have the variable terms next to each other as well, so I know what exponents I'm going to add in this case. 3 times 2, we can just simplify. That's 6. N to the 2/3 times n to the 1/2. That is the product power, so we have to add those two exponents. So off to the side, I'm going to take 2/3 and change that to have a common denominator with the 1/2. So in this case, common denominator between 2 and 3 is going to be 6. So I need to multiply each fraction by a certain number so that I can get a common denominator of 6. So 3 times 2 will give me 6 for the first fraction. So I multiply that in the numerator to get 4/6. So the first n is actually equivalent to n to the 4/6. And our second one, 1/2, I need to multiply both numerator and denominator by 3. So 1/2 turns into 3/6. So that second n is going to turn into n to the 3/6. In this case, now these bases are the same and they have the fractional exponents with the same denominator, so I can just add those two together. So 6 times n to the 7/6. That's it. All done. It just says that you're not supposed to have any fractional exponents in your denominator. This one is not telling us to put it back into radical form, but we could if you wanted to. Just a quick little show you, only the 6 has a power of 1, so 6 would stay outside the radical. And then I would take the 6th root of n to the 7th. That answer is perfect, but we're going to practice these in just a moment, just kind of give you a little tip for the next set. Remember, if I'm taking the 6th root, as long as the power under the radical is greater than that outside, then you can reduce them. So this would be 6 times n times the 6th root of n to the 1st. This n on the outside actually represents 6 of the n to the 7ths that are on the inside. All right, number 8, n to the 1/2 times 3n times 3n. Okay, not too bad. So again, I'm going to rearrange. I'm going to take just my coefficients on the outsides, multiply those together, and then I'll take each of the variables with their exponents and multiply them together. And if you notice, I added the power of 1 for the other two n's that are on the back end. You don't have to. Some people just like to see it. So 3 times 3 is 9. N to the 1/2 times n. So that would be n to the 1/2 times an n squared. And again, we're going to change that power of 1/2 to be something over, nope, we don't have to change that one. What am I doing, guys? Seriously, we're going to change the 2 to have the same denominator. So I'm going to change this guy, my bad. All right, so n squared, 2 over 1 equals how many halves? There you go, that's what I was thinking. I need to multiply by 2 in the denominator and numerator to get 4 halves. So we're going to change 9 n to the 1/2 times n to the 4 halves. Just made that have a common denominator, and now I can add those two powers together. So our final answer is 9 times n to the 5 halves. Again, that's all it's asking us to do. I'll show you how to rearrange that like I did number 7 in the next set. All right, numbers 9 and 10, getting a little bit uglier. These we are going to use our quotient property. We are going to have to subtract the exponents. And if you'll notice, we also have a couple of negative exponents. So anytime we have those negative exponents, we're going to have to move those guys in order to make them positive. And it's only the single term that has the negative exponent. So in example 9, I'm going to go piece by piece. So I've got 2x to the negative second over 2, and I'm going to go ahead and keep the x to the 3 halves, y to the 3 halves. The first thing that I notice in this example is that I can reduce the 2's. I can divide my coefficients like always. So 2 divided by 2 is just 1. All right, our next step that we could go with this is because this single x up in the numerator has a negative exponent, I can pick that entire thing up. Remember, we're flipping it upside down, so x to the negative 2 equals 1 over x squared. But because we already have a fraction in terms in the denominator, we're going to just stick it down in the denominator with the rest. So I'll put my x to the second down here, my x to the 3 halves, and my y to the 3 halves as well. So what does that leave me up top? Well, like I was showing you in this part right over here, if I take that x to the negative second term and flip it, I'll have a 1 in the numerator. We need to combine these two terms together, x squared and x to the 3 halves. So 2 over 1 equals 4 over 2. Check. We just did that a few moments ago. So I have 1 over x to the 4 halves, x to the 3 halves, y to the 3 halves. And when I combine those terms, I'll have 1 over x to the 7 halves, y to the 3 halves. All right, it doesn't want any fractional exponents in the denominator, so we're going to go ahead and convert it back into a radical form because it doesn't say that we can't have the radicals. Thank goodness both of these have the same root. We're taking the second root of each of them, so that means I'm going to take the square root of x to the 7th, y to the 3rd, and that's all in the denominator. That actually does reduce out, and I've run out of space. So I'm going to have to move that up top. So 1 over the square root of x to the 7th, y to the 3rd. So remember guys, because it is a square root, we're looking for pairs. This would be x squared times an x squared times an x squared times an x to the 1st and a y squared times a y. So when I'm factoring out my common pairs, I've got 1, 2, 3. So x cubed representing my 3 pairs of x squared, a single little y, just one of those, and then the square root of xy left over. That is your final answer. Pretty ugly. If you need me to go back through that another time, I sure can. More than happy to. We'll do something similar in example 10, but I'm going to go ahead and reduce the 2's that I see here. They both have an exponent of 1. I can take care of that. And if you notice, you've got one term that has a negative exponent. I'm going to move that guy down as well. So I'm kind of shortcutting a little bit because we went step by step by step, every single little bitty step in number 9. So we should be able to go a little faster with 10. So the 2's reduce, leaving me with an x squared in the numerator. Y to the negative 1 becomes y to the positive 1 in the denominator, and y to the 1/2 stays down there. Already has a positive exponent. So 2 terms in the denominator, we need to add those together. So I've got y to the first and y to the 1/2. That will give me y to the 1.5 or 3/2. And then your last step for that one is just writing y to the 3/2 in radical form. So I'm taking the second root or the square root of y to the third. Okay, check. Can you reduce that? You definitely can. You've got a pair of y's, one pair of y's, and one guy left over. That's all underneath an x squared. So your final answer for number 10 is x squared over y times the square root of y. If you hear any little weird noises in the background, my dog is in the background, crying like a big baby. Cry baby. He's a sweetie. I'll show you what he looks like. Say hi, Codes. Hi. And see, this is why we don't let teachers teach from home, because you get random stopping of the lesson just so you can see a picture of my cute little dog. All right, back on track. Here we go, guys. Simplify and make sure you only contain positive exponents. So power to a power. The -3 does have a power. It has a power of 1. We're going to raise it to the third. R to the -2, we're going to raise that. So in this case, when we have our power to a power, we have to multiply our exponents. So that's -3 to the third power, and then r to the -2 times 3. All right, so this means -3 times itself 3 times. -3 times -3 times -3. That is -27. R to the -6th when I multiply -2 times 3. And only positive exponents. That negative exponent is only applied to the r, so that's the only term that I have to flip upside down and put into the denominator. Your final answer for number 11 is -27 divided by r to the 6th. In number 12, you're going to do a similar process. This one, everything's being raised to the -2nd power. So that is 4 to the first, and we're going to multiply that power by the -2, and p to the -2nd, multiply that power by -2. So this becomes 4 to the -2nd times p to the +4th. The only term that is negative is 4 to the -2nd. So this is technically just like the last one, all over 1 at the moment. So that 4 to the -2nd is going to move to the denominator. We will have p to the 4th staying because it has a positive exponent. Yay, yay, yay. And 4 squared becomes a positive exponent in the denominator. And now you can simplify. P to the 4th over 16. All done. All positive exponents. Fabulous. Last two. Okay, so in this case, this is what I was saying. We're going to do a little more practice with reducing the radicals. So when the exponent of your term under the radical is greater than the root, you're going to look for that set amount in order to factor it out. So we are looking at the 4th root of 64 times the 4th root of x to the 7th. Okay, so your things that you think of for 64. Let's see, 2 times 2 times 2. Let's see, that's 4 times another 2 is 8 times another 2. That gives me 16. All right, still not there. So I would have to multiply that by another 2 to get 32 and another 2 to get 64. Okay, so I can rewrite 64 as 1, 2, 3, 4, 5, 6. 2 to the 6th power x to the 7th, all under the 4th root. So again, I'm looking for a group of 4. There are 6 2s, so I can take out a single group of 4 2s. And then when I look at x to the 7th, again, kind of a shortcut, subtract those exponents, x to the third, so I can take out a single group of x's to represent 4 of them that are within this section, and then I will have an x to the third left over. So 6 minus 4 is 2, so under my 4th root I will have 2 squared and x to the third. You can then simplify 2 squared, that is 4. So your final answer is 2x times the 4th root of 4x cubed. Remember, if you need to write every single piece out, by all means, guys, do so. Don't hesitate at all. All right, so last example, the cubed root of 216. I definitely know it's not 2. We've already tried that. So what about 4? 4 times 4 is 16 times another 4 gives me 64. Nope, that's too small. We know it can't be 5 because that will give me 25, and then 125, it's got to end in a 5. So 6 times 6 is 36 times another 6 should give us 216. Check. Awesome. All right, with this example, we have a negative under the radical. You can only take a root of a negative if it's an odd root. We did jot that down one day. We didn't practice a whole lot, but just know it could possibly be on your quiz, so make sure you practice those. All right, so if the cubed root of positive 216 is positive 6, then the cubed root of negative 216 will be negative 6. That works out perfectly. Done. So I should write that so you guys can see it as negative 6 to the third power. And then we also have k to the 5th. So the cubed root of negative 6 cubed undo each other to leave me with a negative 6. If you think about k to the 5th, that is k multiplied 5 times. I can factor out one group of 3 k's, and I have a k squared left over under your radical. So your final answer for number 14 is negative 6k times the cubed root of k squared. I hope you guys did okay with this. Don't forget, worksheet D is another really good review. It does all of the properties of exponents in the beginning, 12 problems, I believe, and then it goes back and forth between the rational exponents and the radical form in those last 8, and there's a couple at the very bottom for evaluating. So that's another really good one. Your quiz is all multiple choice, so don't fret too much. You guys will be able to stop and check yourselves. Let me know if you have any questions, and I'll see you tomorrow.